Well, good afternoon. Apologize, I do not speak Polish, and I hope your English is good enough to listen to me. And what I'm going to talk about are basically examples on how our customers using our product would use it to monitor Oracle-based systems and voice over IP. Now, for us that don't know about NetScout, NetScout has been in the industry for about 30 years now. And for individuals that are familiar with monitoring systems, and you know some of the historic terms used for monitoring and protocol analyzing, you have probably known the brand Sniffer. Well, NetScout some years ago purchased Network General and incorporated their products into the system where back then it was mostly based on remote monitoring or RMON. And since then, NetScout has been growing and growing worldwide now. I represent NetScout on the engineering side, and our partner Bacotech supplies our product into Poland and Eastern Europe. But as I said, this particular discussion is all about monitoring Oracle-based systems and voice over IP. But when you see what I show you on these slides, really at the end of the day, from our point of view, we are all talking about other applications that are using, that companies use for Microsoft, like Microsoft Exchange. The database services using MS SQL, we manage Active Directory, and all these components are indirectly linked one way or another. And that's the unique side of our particular environment where, from NetScout's perspective, we monitor network infrastructures. The network infrastructures have core backbones, and whether it be an MPLS network or within a data center. So within those environments, you got trunks, main routes of data paths between branch offices and your data centers using many different technologies. But what's true about this particular environment is those trunks carry lots of different traffic. And this is where NetScout's solution is really oriented towards packet capture. Every single packet that we want to assess is, captured into a probe-based technology, and then from there, deep packet inspection is taking place after you put together all the sessions between the clients and other clients, if it's voice or video, and voice and servers, if it's traditional data. And when we actually speak to customers, there are many, many, many reasons why applications particularly don't work, or the user experience is not very good. And when I talk about user experience, it could be web browsing, access to a database, it could be voice quality. There's so many different reasons for that. And for us in network operations, you look at things like packets being dropped, or the traffic on particular trunks are loaded or not even delivered efficiently if you're talking MPLS or IPVPNs, being transported across broadband type networks. Also, what you'll see through this particular presentation, that many of the applications that you are deploying potentially are not just one protocol or just not one connection between a browser, typically using HTTP, to a front-end server, but typically multiple tiers. And then after you get into those multiple tiers, then you probably have dependencies on other applications to be working efficiently as well. So when we talk about monitoring an application, NetScout calls that a service. So you would not have a voice service without SIP or some type of control plane soft protocol. You wouldn't have a voice service without RTP, which are the streams between the endpoints. And then managing that would be totally different as a service when you combine SIP and RTP together as a service. Would be totally different from applications using an Oracle database Chances are you may have a thick client using a specific port number, but chances are you're going via HTTP. You're going through load balancers, front-end servers before you even get to the database itself. So there are many, many areas that you may potentially have a problem, and when people come to NetScout, they say, not only do we want to understand what the problem is, I don't particularly like the phrase root cause, but that's what the market kind of generalizes the subject to be. But we try to identify where the problem is as well. And when you talk about multi-tier applications, you start getting into a lot of different things. So the first example we're going to give is on Oracle. And when you start looking at the relationships between the client community, now the client community, the NetScout, is the branch office, or it's an area of your domain that you have an interest in. It's not the data center. It's typically where the users are located. Now, the client communities can be, a call center. And if you think about a call center, the call center has data applications as well as voice applications. But the client community would be the call center. If you got a big main office somewhere, you might have different departments within that. But all these are client communities to us, effectively creating the demand for the service. And then when we start looking at the service, right, as I said a little while ago, we are talking about typically multiple tiers of applications that communicate within each other. And when you start jumping and making these hops between either the components of the infrastructure or through the services supplied by a front-end server or a database server, or interacting with another dependent application, for instance, DNS. Now, we all know if DNS is not working in your network, people are not connecting to your front-end servers. And if you have inefficiencies or problems on the network, then you're going to start dropping packets. Right? But most of this will always increase time, and that's where the poor user experience comes in. So we look at everything from the point of view of a packet leaves a client, it traverses the network, you got response times, you've got basically the throughput associated with the packets, and then at that point you got the session level information as well. And then you got the multiple components that may be creating new sessions to be able to establish the service that the client is actually experiencing. Whether it be web browsing on just a standard old web page, with back-end components supplying the data or the content that the web service is supplied, or it could be a database. And for all of us that know SharePoint, SharePoint's not just HTTP and interface to a web browser or a web front end. It is actually a whole host of services behind that could be, the imagination of the developers of SharePoint. So when we start looking at these multi-tier applications, then we start looking at the infrastructure associated with how to capture the packets. The packets are basically the food that supplies our system with the information to determine what the potential problem is. And as you see from here, we got the user community sitting out in the network. They're dotted all over the country. Whether you're a service provider or you're an enterprise customer or a cloud service provider, you always will have to be dealing with user communities. We have our monitoring system. And then from that point, you got your multi-tier application from top to bottom. And then from our point of view, we actually sit there and we actually have what we call assessment points throughout that whole infrastructure. Because basically what we want to do is capture every single packet that we can, because every single packet is effectively supplying us with the food that is going to provide our monitoring system with the information that helps you determine what the problem is. Now, the problem could be determined proactively because of changes in baselining. It could be showing you changes in thresholds, or it could help you actually try to find what the problem is through some type of investigation. But if you actually are just capturing just at the front end, and you see what's going on between the user community and the front end, and that's all you're assessing, then you'll never see what the kind of problems you're having in the back end. And so we have this session, this technology called adaptive session intelligence. And what this effectively is doing is capturing every single packet in the network, analyzing every single packet with deep packet inspection, and then from there creating metadata. And now the packets are created in a way of that they're always going to be there. Well, not always. They're going to be there for quite a long time for future investigation. Then the session records, the actual experience of the client going through the whole tier, everything that is considered a TCP session or a session either in Oracle or in Voice, they're actually kept as records. And all those sessions are related to every single point in this infrastructure that is capturing the data. And typically what you'll do is that you'll start using a packet broker, which will aggregate the traffic into our monitoring probe. That's what's collecting the data and actually creating the session records itself. And these packet brokers are supplied by many vendors. NetScout supplies our own with the taps as well. But at the end of the day, we're actually talking about monitoring an open system here. So no matter where you are in developing the monitoring architecture, NetScout will be able to bring in and actually monitor the applications itself. And then you can see there's your Oracle servers there's your web servers, there's your load balancers, there's probably your front end that's terminating HTTPS sessions. So it's a very complicated environment. And then what's interesting about this environment now is that depending on what kind of architecture you have in your data center, you could be using software-defined network, you could be using VMware, they could be on, you can be deploying all this in a world full of hypervisors. So when you start getting all these other components in a distributed computing architecture, how do you actually collect all this data? And this is where these multiple assessment points are really coming in. So you need, if they're running on hypervisors, you most likely will be running some type of virtual machine for your monitoring system to collect the data. Or you can have a standalone, just filling up with the data coming in from the packet aggregators, and that's all there for you. Now, but what's interesting about this particular environment is, what we see is, basically a web browsing application. Everybody sitting at their desk and they connect to SharePoint that may be connecting to an Oracle backend server, or whether they're using, one of, Oracle's many applications to connect. Once you start deploying that system, you have to understanding what the architecture of the application is, or the server. So from what we have here is at the very top level, we got our user communities. A load balancer effectively can be considered a user community because it's the source of the TCP sessions that's actually retrieved the data from the next level down. And then you got all the user communities out in your wide area network, or within the local branch if the data center is in the same building, and then they're connecting to the front end. But you still have to have a look from who's creating the sessions that are actually going in and collecting the data. Then from there, those front end, those users are connecting typically to front end servers, right, that are just really terminating the initial sessions and doing the load balancing or some type of application conversion to get the data from the actual proper servers. But the other thing that's really important, that these particular servers may have dependencies on other servers themselves. For instance, DNS. If the user communities go out there and they start typing, a URL, and if that URL is not, actually within the DNS system, those users are not going to connect to the server. Or if there are a lot of issues between a server being programmed to connect to a URL or a domain name to connect to a server further down the multi-tier environment, then you got to know all these type of things. And so how do you determine that? The other thing that these particular maps also show you is not only the dependencies the clients have on front-end servers, the servers on back-end servers, and also services such as LDAP and DNS. If you talk about Microsoft, SharePoint, it may have an Oracle component, but you may have a connection into SMTP to send email. So there's another dependency that that Oracle service may have in generating a component of the actual service that the users are using. So from there, also, this particular map is also very useful to not only telling you where your critical errors are and what servers and how the servers are being used when it comes to the balance of the sessions between them, but it also can start giving you errors such as retransmissions, or when the timeouts are not acceptable, or the latency is so high that the load balancer is now really going to another server. And if you got a server cluster out there, then these maps really start helping you actually understand, which server is actually struggling to keep up with the volume of requests that are coming in. Now, with us, we actually think of transactions in two ways. In the case of Oracle, we see Oracle communication at the, to the database is primarily one type of transaction. But then the other type of transaction we see is at the TCP layer. And we don't confuse the two. TCP transactions are exactly that, transport. And then you got the application layer messages that are coming through that are application related. So you can see all that within this particular diagram as well. But when you start getting into the actual way of detecting what is the biggest problem, then we start going into our monitors. So you can see here from our multi-tier environment of Oracle, we got the user communities, we got the front-end servers, and then we got the back-end servers. And then what we don't show you there is, and point out, is the relationship to LDAP for authentication and DNS for name resolution. There it is. And, of course, because Active Directory supports all these protocols, of course, now you have a system that can actually monitor Active Directory's integration into this particular application. So what's nice about this particular way of monitoring is that once you start highlighting a relationship problem between a front-end server and a back-end server or user community, you can drill down then into basically the reporting tools. And our monitors are very good at detecting at this level problems with the Oracle database themselves. So you can see here we got everything in relation to latency or performance, the volume of actually the number of requests going to the Oracle database or the Oracle services, and the number of failures. This is a spreadsheet form, so you can actually then start sorting based on what you're investigating as potentially the problem. And then on the very bottom, there's a way to actually look at the relationships between performance and latency, server load and latency. And then what a lot of companies are really interested in is actually here the error codes that we're picking up from the actual messages we're getting between the Oracle database server and the actual clients. Now, whether the transport system is HTTP or not, it doesn't matter to us because we're always looking at from a deep packet inspection perspective and the payload associated with the Oracle traffic. And what's probably it's not shown up here is that, we got a little tab here where you can actually add the client community that's creating the problem, or experiencing the problem, and at that point you can start seeing if there's a problem only with one particular group of people or it's common amongst many groups. And then the last thing that we can do that's very, very useful with Oracle is that we can actually monitor as part of the service on a per database basis. So if you have a database name, you can assign that database as part of the service, because as you know, an Oracle database server may have many databases in it, and the service that you want to define may be specific to a particular database. So you can see there's the Oracle server with 4 errors. There's the errors are listed up on the top, and then you finally come down to the bottom here. And when you start drilling into the system, and what you've seen so far is a multi-tier application map. You see basically a link between 2 servers that are having a problem. One click of the mouse, you're into a server monitor, and you can actually see where the potential errors are here. And then, actually here, this is, okay, yeah, we're going on here. So, and then this particular level, this is the next level drill down here, and this is where you start seeing the session-related information. So you see an identity called Jack trying to get to a, well, actually, if you see that, he's actually J-A-R-L, or J-A-K-L, and he's trying to access a database called XYZ. And unfortunately, there is no user being authenticated as Jack or Jarl or Jack. And so he is failing because he's not actually authenticating through LDAP. So it's not, at this point, it's not even an Oracle problem, it's an LDAP problem. But then if you start getting into Oracle problems where there's not enough space, where the table name has not been allocated, these are all the type of message codes that we can determine from the Oracle side itself. Now moving on to the second part of the presentation is we're talking about unified communications or voice over IP. Now what's interesting from our perspective is that I just talked about 5 or 6 or 7 or 10 different products, problems you would have on your data side, but the system also, your infrastructure is still potentially carrying voice and video. So how do you manage that at the same time without having to have a separate system to monitor only the unified communication side? Not only do we support all the vendors out there, we actually are very good with Microsoft Lync and the Cisco products as well. So we're still trying to keep to the multi-vendor approach to monitor a standards-based system. And in this particular example, we have this with the data side with Oracle, SharePoint, Microsoft Exchange, with the dashboard effect of actually monitoring the quality of the services that each of them are supplying you as part of your network infrastructure. We have one tab that's actually focused on unified communications. And what's an interesting particular problem here is that most people, they have a problem with data, they send an email. But if they have a problem with voice, they call. They call a call center or a help desk. So you have a surface here that actually is able to search on a telephone number and start identifying the problems there. Now this is very clever because the actual telephone registration on telephone call is made by a protocol called SIP, but the actual voice streams themselves are actually using RTP. So with this system here, having the ability to actually correlate the traffic between SIP and to the RTP session is what's really clever here, and that's what's really necessary for a lot of voice systems over IP these days. So again, we have the same type of monitor approach. The whole thing is, at this time, what we're doing right now is that we're looking at the SIP protocol and all the errors associated with SIP. You can see the call server names, you can see the types of problems they're having, and then finally we got the error codes down here that tell you quickly what the potential problem is. And then when you start getting into it, you can actually add another column here and look at the client community to see if they're having the same problems, across many SIP trunks, or is it only one call manager is having the problem. Then we have other views here where you can actually see these problems common between a central site that you're investigating and other sites are talking about. And then you start looking at the statistics that you can compare against each of the sites. And finally, you go into all the different types of reports that you can offer when it comes to difference between payload type problems and problems with mean opinion score or single direction calls or quality of service marking mismatches. These are all things that you can look at really quickly because, again, we're just deep packet inspection, deep packet analysis, session awareness. And then at that point, we go and drill down, we go into the media monitor, We're listing all the calls that are happening within that particular session. We start giving you some indications of the problems, the telephone numbers, where they're located, to the point where we actually can show you a map of the actual call stream itself. And then at that point, there's your session border controller. And at that point, that could be a source of a problem or not. And then at that point, you got your monitoring systems. You can see things like whether the voice is too loud or voice is too soft. Because most systems that are monitoring voice over IP are just using mean, opinion, score. With our solution, we're actually reassembling the streams, assessing the sample of the voice against the codec, and at that point we can see whether the voice is too loud or too soft, whether there's echo, and whether there's any background noise. And these are all part of the, the reports that we can issue through these drill downs. But as I say, everything is, basically drilling, starting from a particular monitor, for possibly from a dashboard, and you're just constantly drilling down. And the other thing for us that like, packet decodes is that you always have the ability to actually choose a stream and drill down into the packets and actually look at everything from a packet perspective. And whether you want to integrate that and, and export that and look at a Wireshark, it doesn't really matter to us at this point because we have the packet sitting on the probe technology. So what we covered in the last 20 minutes is kind of very, very simple in many respects, but it's having a monitoring architecture that can do this for you. Is basically be able to see the relationships of sites and communities against the servers themselves. And rather than just troubleshooting one session between a client and a server, you actually have the ability to look at all the aggregate sessions and see if it's a problem with the site as well, and then drill down to the particular session. The whole thing is, we're always looking at the server farm as and the multi-tier environment as potentially a source of the problems. Whereas I said, a lot of these applications have dependencies. Here's one that a lot of people don't even realize when it comes to voice. If a voice handset does not get an IP address, they're not talking before you even get to the session initiation protocol. So there's a lot of dependencies going on, and that's very, very important. And then the other thing, the relationship between the transport system as basically the infrastructure itself, the enablers and the applications, they work all together. So it's not just about packet drop and response time and jitter potentially, but maybe a combination of a lot of things. So we differentiate between basically application performance monitoring and monitoring the network infrastructure itself. And so we have the traffic monitors as well. You still need to look at bandwidth cycles when it comes to capacity planning and drill down to what is known and what is not known. And then finally, you have the service monitors themselves. And the real important things to us is be able to take all the things that are important to running an Oracle or a voice service and group them together as a service. And it's not just the one application that does the job. It is basically a lot of applications working together to deliver the applications to your end clients. So I think I've run out of time. Is that right? Or
maybe any questions? Do you have any questions? Nope. So thank you very much for your lecture.
You're very welcome. Thank you very much.